Hi friends! I hope everybody's doing okay today. We're going to get back to basics and talk about lightning because, you guessed it, I also think that's an impact. Let's go. About 6 months ago, I started, I'm putting it all together that these disasters are all actually different manifestations of impacts. And I realized that the one component that they all have in common is lightning. Name the disaster, and there's always lightning involved. I've been wanting to do a video about lightning for a while, but I've been kind of afraid to talk about my thoughts on lightning. And I got really excited this morning when I saw this article on my home screen because this professor, he studied, in case you don't know what fulgurites are, they're like, this is what they look like. This is when lightning strikes the ground, you can dig these up after a lightning strike. So this professor bought one of these online, and inside it he found this, and it's a phosphorus material that has never been found on Earth. It only exists, minerals similar to it can be found in meteorites and in space, which says that this is of meteoric origin. He stopped short of saying that. He's claiming that the lightning strike itself is what created this material. I think that he's wrong about that. I think the material is what created the lightning strike. And I think that makes a lot more sense. It even looks like a small meteorite. It's got little pits on the surface. When asked if the formation of this material could be common during lightning strikes, he said it could be. We do find materials like these spheres in a number of different lightning strikes, so I would bet for certain there are other occurrences like this in lightning strikes and probably beyond that. According to the professor, it's important to understand how much energy lightning has because then we know how much damage a lightning strike can cause on average and how dangerous it is. Not only that, we can figure out a way to harness this stuff. We have energy demands, and these things can solve them for us 1,000,000 times over. And it's just something even more sinister going on too, like climate change is being dumped on human beings for driving cars when these things are seriously, they can totally screw up our environment, our atmosphere. They can totally screw up. I mean, they can move entire land masses, all right? Oh God, I have so many videos to make. The Americas weren't discovered until the 16th century because they didn't exist before the 16th century. Somewhere between, I want to say 1487 and 1566, there was a series of comet impacts that totally reshaped the geography of our planet. Wait till you see, oh God, wait till you see what I've done. Don't miss the map episode, oh my God. It's a good indication that this is an impact event. They're just different manifestations. So it's like baking or cooking, right? You have different ingredients. You're cooking them at different temperatures. And if you live in a high altitude, you have to use different temperatures. And you end up with either a cake or a bread or a brick. Each comet is a different recipe. It's being baked at a different temperature under a different pressure. So you could have two of them in the exact same parent body, but will have completely different outcomes on Earth based on the day they fall, the time they fall, the place they fall, you name it. So we might experience one piece of a comet as a hurricane, and the other could cause an earthquake somewhere else. These are some of the more dense particles of the impacting body that were not vaporized by their transition through the atmosphere. So they would likely contain a high percentage of nickel, iron, and so they would be metallic. And as they pass through the ionosphere, they would be electrified and then electromagnetically interact with the surface of our planet, because Earth is also a giant magnet called a geodynamo. We have a magnetosphere. We have a north and a south pole. The impacts are more likely to happen closer to the poles. The bigger impacts and more frequent impacts. That is also why the poles are in a constant state of cold. But I'm going to have to save that for another day. I'll explain that another day. I know it seems counterintuitive, and that screwed me up for a few months until, I'll give you a hint, it's called superionized ice. If you check that out, you'll probably guess where I'm going with it. So anyway, a lightning bolt is just a solid chunk of one of these things making it through, and going to be moving so fast. Lightning moves at about 220,000 miles per hour, which is very consistent with a piece of a comet, for sure. So the human eye can only detect motion in its field of view that's slower, that's under 38,000 miles per hour. So 220,000 miles per hour is much faster than the human eye can detect. Because of that, all we see is flash. So yeah, I mean, these things are going through the atmosphere. They're being they're adding electricity, you're adding heat, you're adding pressure. That's a chem lab. Did you ever realize our atmosphere is a chem lab? It's probably the inspiration for the first one, because ancient people knew all of this stuff. I'm telling you. I can't wait to get into that. Okay, so this is what they say. Lightning is a large-scale natural spark. Oh, they is Science Learning Hub. They're out of New Zealand. Lightning is a large-scale natural spark discharge that occurs within the atmosphere or between the atmosphere and the surface of the Earth. Highly electrically conductive plasma channel, yes, is created within the air. Yeah, I agree. But they don't say how, they just say it's created, as if it creates itself, which is kind of not possible. And when current flows within this channel, it rapidly heats the air up to about 25,000 degrees Celsius, which is a little over 45,000 degrees Fahrenheit, which is about 4 times the surface of the sun, the temperature of the surface of the sun. It's warm. The lightning channel is an example of terrestrial plasma in action. And it's this kind of stuff, by putting the word terrestrial there, it's like they're limiting you from seeing the possibility, this could be extraterrestrial plasma in action, which is much more likely, don't you think? Isn't it kind of strange to think that the air could just whip itself up into such a frenzy without any sort of input of energy from somewhere else? There's no energy. There's no explanation for the input of energy here. It's like they're saying that this energy generates itself. And I don't think that's possible. And then they go on to make this, whole case for natural terrestrial plasmas, in case we were, a little unconvinced by what they say here. Just so you know, there are other natural terrestrial plasmas on Earth. Temperatures in the narrow lightning channel, okay, we got a narrow lightning channel. What made the channel in the air that can reach 25, that can heat up to 45,000 degrees Fahrenheit? How? The surrounding air is rapidly heated. How? Causing it to expand violently at a rate faster than the speed of sound. Why? I don't. It's just, you're telling me that it's heating up super fast, so fast, faster than the speed of sound, that it's going to create its own sonic boom. Come on. That's against the laws of physics. That's like, if every action has an equal and opposite reaction, then it's also true that every reaction has an equal and opposite action. So they're talking about a reaction with no action. No. Wrong. Similar to a sonic boom. It is a sonic boom. It's the sonic boom attached to the meteorite. At about 10 meters out from the channel, it becomes an ordinary sound wave called thunder. Right, that's true. If you're really close to where that sonic boom lets out, it sounds like a freaking cannon. My car got hit by lightning once, and I thought that somebody shot us with a shotgun. It was so loud. And I did see a rock coming down in front of us. And at the time, I thought it was black. I thought it was a piece of the highway that had flown up and was falling back down. But now I understand that was a meteorite. We got hit by a meteorite. It was just a small one, but it was electrified. Yeah, it fried the whole electrical system on our car. We had to go back. We had to drive home like 700 miles from vacation in limp mode. Oh man. And I want to send a quick shout out to 2 people who were in the car with me when that happened, Dan and Mariah. What's up, guys? It is the formation and separation of positive and negative electric charges within the atmosphere that creates highly intensive electric field needed to support this natural spark discharge that is lightning. So they're talking about the buildup of potential energy. Okay. The formation of electric charges in the atmosphere is due mainly to the ionization of air molecules by cosmic rays. Now we're getting somewhere. Cosmic rays are high-energy particles such as protons that originate from outside the solar system. Yes. See, that's code, right? I think this is code for comet. High-energy particles, which is exactly what I was talking about in the Wakari Island video. High energy particles, or like I've been talking about in every video, that originate from outside the solar system. They're not from our sun. It's high energy from somewhere else. That's comet. There's nothing else that comes from outside of our solar system to here that I know of, besides on a routine basis, besides comets. On colliding with air molecules, so they have to be moving really fast, they produce a shower of lighter particles, some of which are charged. Within a thundercloud, the rapid upward and downward movement of water droplets and ice can separate and concentrate these charges. The negative charges accumulate at the bottom part of the cloud and the positive charges towards the top. I'm not a scientist. I have no way of knowing if that's true or not. It sounds like more of that scientific gobbledygook that makes my eyes glaze over because it makes no earthly sense. Water droplets and ice crystals. Now they have us believing that the ice crystals form because it's so cold up there, right? But comets are dirty ice balls that contain high amounts of water ice. What if the rapid downward movement of water droplets and ice crystals is due to the impact of a piece of a comet, charged up? As the area of negative charge at the base of the thundercloud builds up, it induces a region of positive charge from to develop pieces of the same parent body. I don't believe that. I think that the charge is already there.
Like maybe there is no gravity. Maybe it's all just a harmonic thing.
They're just hit over and over and over because they're somehow, charged up, and they keep attracting.
Maybe it's all just a harmonic resonance thing. If it's attracting the same, from pieces of the same parent body, if they're somehow harmonically, maybe there is no gravity. Maybe it's all just a harmonic resonance thing.
Although invisible to the naked eye, it allows electrons to move from the cloud to the ground. So there is an interaction between lightning and the ground. It's not just the ground being passively attacked by lightning. There's some sort of corroboration going on, which is weird, right? Even trees carry a small electric current which is probably why they are often hit by lightning. And it all kind of fits. There's like a common sense to what I'm saying that is lacking in what I'm reading here. Tell me if I'm mistaken, please.